Welcome to Time Series. This topic we still employ regression modeling, but this time your X variable, instead of representing, let's say, your past A-test score or the number of Facebook friends that you may have, this time X actually represents time. So the crux of today's topic is observing how Y moves according to time, and maybe we'll be able to predict Y based on some patterns that we might be able to pick up. Time series or related subject forecasting is quite important in everyday subjects. So for example, the governments may use time series forecasting to forecast, let's say, interest rates or unemployment figures, or maybe tax revenue for upcoming policy initiatives. Or let's say even the faculty here might be forecasting student numbers in order to either hire or fire new people or implement additional resources. Okay, let's go through an example. So let's say we have data on annual sales graphed according to time, where let's say the number 1 represents your first year and number 2 the subsequent years, and so on and so on. So we can see how your sales of this company is traveling across time. So the basic assumption of time series forecasting is that the factors that influence Y in the past will continue to influence Y in about the same way. So the crux of time series analysis is to identify and isolate these influencing factors. According to the classical multiplicative time series model, it states that Y can be explained across time based on the following key factors. So the first key factor is whether there's a long-term trend. So is the trend maybe positive in the long term, or is it negative in the long term? The second factor is there a seasonal component? So maybe in certain, let's say, summers or certain winters, you might see higher sales than normal. And does that pattern repeat itself over time? And then is there a cyclical component? So these are patterns that occur, let's say, between 1 to 5 years, for example. So that might represent, let's say, some sort of business cycle. And the last component here, so if it's not a trend component or seasonal component or cyclical component, then it must be some sort of irregular component. So that might, let's say, for example, represent some sort of accident or some sort of disease. So let's say these sales represent, let's say, annual sales of milk. And let's say in a certain year, we've experienced mad cow disease. So that might be a spike or a heavy spike downwards on sales. Okay. So looking at this chart now, to identify these individual components might be a bit difficult because of all the noise that's here. So what's pretty useful to do is try to maybe smooth out this series, right? So we've got a couple of techniques here to sort of maybe reduce the noise a little bit. First technique is known as the moving average, and the second technique is known as the exponential moving average. One of the major pitfalls of using time series analysis is the assumption that the past data and current information can be used as a guide to the future. As you can imagine, this is rather mechanical, as it does not consider other important aspects such as personal judgments, business experience, and change in technologies. Although there are models that incorporate these things, due to the simplicity of time series analysis and if used concurrently with the aforementioned factors, time series analysis can still provide an excellent way to forecast variables. Well, this brings us to the end of the course. Hopefully the concepts learned in this course will be useful to you and your careers. It's been a pleasure, and all the best with your remaining university studies.